Good morning, dear friends. And Dr. Rajesh, Associate Professor, Department of Physics, Science University. Without giving the name, I just wanted to give some example. Assume that your mom asked you to go for shopping and asked you to brought some brinjal. What you will brought it? You just have a bag and just brought the brinjal and put the brinjal in the bag and you just keep the brinjal in the home, right? In the case, you are grown up and you wish to have a building, a beautiful house near the forest. It's a remote area, and you will build the houses, and you wanted to give the electricity to the building. Now, how you brought this electricity to the home? So you need specialist appliances for bring this electricity somewhere far from the city side to the remote area of your home, right? So for that we needed a particular apparatus, we call it as transformers. Okay, have you ever wondered that how the electricity is transferred from one point to other point? That is with the help of transformers. Transformer is a device that can use to transform electric energy from one point to another point. In other words, you can say that it is used to convert low alternating current into high alternating current and vice versa. So the first example what I have told about the bus direction and the large towers, it is again a conducting material. It consists of wires. We have dams. Using dams, we have created hydro powers. Nuclear powers also we can generate electric powers, and also thermal power. See, these three plants have generated electric powers. That has to be carried for a longer distance. For that, we have need a conducting wires. That is why you have seen the large towers in the rural sites. Whatever we have seen in the corner of the street, it is also a transformer. So this transformer is used to control the power which is generated in the, assume that if you generated a power, very huge power, 20 megawatt power in a power station, and that is directly given to your household appliances, what would happen? All your household appliances will be bursted out. So control that, we have a transformer in the corners of our street. That transformer we call it as step down transformer. For example, we have a nuclear power station in Kalpakkam. We generated powers and we have to transfer the power to the Chennai. So almost 60 to 70 kilometers, right? In between we have two transformer centers. That transformer centers are called a step up transformer. What is the use of step up transformer? A power which is generated and transformed through the conducting wires. Through the conducting wire there must be a dissipation of energy. So that the energy dissipation should be enhanced again. So we need to have built a transforming unit then and there in between two different points that we call it step up transformer. Whatever the energy is less, it has to be step up. Step up means increase the energy. And then it has to be connected to a household appliances using a step down transformer. So this work of a step down transformer is controlled and giving the lower energy alternate current to the household appliances. Now we just go to the construction model. This is about the transformer and its uses, what is the necessity of a transformer. A transformer works based on the principle of mutual induction. As you all know, what is mutual induction? If you keep two coils nearer to them, if we changes the current in the first primary coil, so what happens? It is induced in a EMF in the secondary coil. If there are changes in the primary coil current, AC current, it induces EMF, we call it as mutual induction. What is actually happening there? We are changing the AC current, the positive to negative. This continuous changing of current will induce the magnetic field around the primary coil. This induced magnetic field created in the primary coil will transfer to the secondary coil due to the buffering. And this secondary coil change in magnetic field will produce a EMF. So this is the concept and this is the principle used in the transformers. Okay, now come to the setup of the transformer. In a transformer, two important things are there in a transformer unit. One is core, another one is coil. This coil, what I have mentioned initially, it is primary AC current. So we have two wind-ups in the coil which is laminated or which is fixed in the core. Normally rectangular shaped core which is made by soft iron. There is a physics behind to why we have this soft iron as a core. Keep on changing in current in the primary coil will cause us a magnetic field variation. When we give the power positive direction, so magnetic field may be higher. When it goes to the negative direction of alternating current, the negative field may be less. This continuous change in magnetization and demagnetization will make this coil is losing its magnetization energy. To overcome this, we have this core. The primary core is made by soft iron. First one is to stabilize the magnetic field variation in the coil due to the coil in the core. The second and most important is the thermal melting point of soft iron is more than the melting point of copper, because our primary coil is and secondary coil is made by copper. The melting point of copper is around 1070 degree. When you keep on changing, you all know that eddy current and energy is dissipated in the form of heat. So you all know that when we lamp on the lamp, what happens after a few seconds, the lamp is getting heated. So this is a common concept that when the current is flows in a particular conduction wire, so it will be created heat. So huge amount of changes, variation in the primary coil will cause the heat. Assume that a material, the core material, is made by a lesser melting point material rather than your soft iron. What happened? This 1070 is for copper. If it is made by core is made by 800, this core will not conduct the magnetic field to the secondary coil. So to avoid this, we need to find a better core which is more melting pointed than the copper. So your soft iron is almost 1470 to 1500 degree centigrade as a melting point. It's more than the copper. So whatever the changes happen in the core will not, the coil will not affect the core. These are the two reasons that why we are using soft iron. The first one is continuous magnetization and demagnetization should not affect the core. That means whatever the flux is created should be given to the secondary coil. And the second one is melting point variation. Okay. So what is happening there? When we are putting the alternating current, primary coil will create an induced magnetic field, and that will be transferred through the core, it transferred to the secondary coil. Due to the change in the magnetic field and EMF will be created, so current will be transferred to the other unit. Okay, it may be higher voltage to the lower voltage or lower voltage to the higher voltage, depends on the number of turns in the coil. Okay, I mentioned depend of the turns. So we have two different transformer. One is step-up transformer, that should be input should be lesser than the output. That means whatever the input we are given to the transformer, it has enhanced and the output should be more. Right? This is step-up transformer. For step-up transformer, the number of turns in the secondary coil is more than the number of turns in the primary coil. What happened in the due to step-down transformer? Step-down transformer should be reduce the voltage, so number of turns in the secondary coil lesser than the primary coil. So keep that in your mind that step-up and step-down transformer, the number of turns will determine, that is, number of turns in the secondary coil will determine the type of transformer. Number of turns is more in the step-up, number of turns is less in step-down transformer. Now, so there might be losses maybe arises in the transformer. So whatever the output efficiency, even in the secondary coil, it depends on the number of turns in the primary coil. Whatever the output, it completely depends on the number of turns in the primary coil. So output of an ideal transformer, normally we are written as ES, IS divided by EP, IP, whereas ES and EP are the EMF of primary and secondary coil, I is the current. ES, IS divided by EP, IP must be 100%. It is unfortunate, it can't be able to get 100% efficient transformer, because we have many number of losses during the process of converting this low alternative to high alternative and vice versa. We may arise some losses, so we may not achieve a transformer which is 100% efficient. The ideal transformer will have 100% efficiency, but practically we don't have any transformer with 100% efficiency because of some leading losses. We have eddy current loss, we have hysteresis loss. This is what this hysteresis is nothing but the change of magnetization, demagnetization. Okay, and then heat loss, Joule-Thomson effect loss. These are the losses arises in the transformer. These losses we can discuss in a separate class. Okay, thank you.